wonderful students. You're welcome to another wonderful edition of Eko Learners Support for WAEC and NECO candidates. I still remain Mr. Oluwale, your chemistry instructor. Today, we'll be taking another interesting topic, which is to explain the calculations on isotopy. Calculation on isotopy. Please sit back and relax and follow me on this wonderful journey.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So our learning objectives for this class, at the end of this class, the student should be able to define isotopy and solve calculations problem on isotopy. What is isotopy, students? If you look at the picture by my right, these are two notes. We have the 100 Naira notes and we have $100 notes. Two notes placed side by side. I believe our students at home knows both currencies, are familiar with it very well. In fact, dollar is the most popular currency in the world. Now, these two currencies have something in common, students. They share the same number. They share the same number. Both of them are numbered 100. 100, 100. But they do not have the same value. If you take both currencies to the markets in Nigeria of today, in fact, I can tell you that the currency here can hardly buy anything. It cannot even buy anything. Why this one can get you a lot. So what are we trying to say here? This is what isotopy is talking about. Isotopy is a phenomenon whereby elements exhibit different mass number. Take note of the word different mass number. Remember I said both of them have different values here. They have different values. Different mass number, but the same atomic number. They have the same atomic number. Please use this to remember. They have the same atomic number, but they have different mass number. If you are presented with a gift of 100 Naira, for those of us that don't know what 100 Naira means, I cannot remember the present exchange rate, but let's assume that is 1,000 to $1, which is far above that. It's far above that now. But let's just take it slow. That is 1,000 to $1. That means $100 is what's above 100,000 Naira. 100,000 Naira, students. 100,000 Naira divided by 100 Naira, which is this one here. That means this one is more than 1,000 times greater than this. So if you lose both of them, if you lose the 100 Naira, probably you might just be sad for a little time. But if you lose this one, you are holding, you know, it's the same one single note. If you lose this one, you might cry for the whole week. In this present day economy, you will cry for the whole week. So what you are trying to say in essence that isotopy is a phenomenon that element exhibits different mass number, but the same atomic number. They have different mass number, but the same atomic number. Example, chlorine has two isotopes, which are chlorine 35 and chlorine 37. Remember, students, that the number that is at the top is the mass number, while the number below is the atomic number. So you can see that the atomic number are the same, but it's the mass number that is different, but it's the same elements. So from the example given, we can see that chlorine has two different mass numbers, which are 35 and 37, while its atomic number is the same, which is what? 17. So that is what is isotopy. Please let us remember that definition And let us remember the illustration. Whenever we remember this illustration, we always remember the definition. So let's move on to understand better what isotopy is. This is a diagram of the atom, where you have the electron, you have the neutron, you have the proton, you have the nucleus. The nucleus houses both the proton and the neutron. As you can see, the proton is positively charged, while the neutron has no charge. The neutron has no charge. So that is the diagram of the atom. The isotopes of a particular element have different mass number. This is another example of isotopes. Hydrogen has 3 isotopes. We have hydrogen, we have one that is deuterium, we have one that is tritium. So if you can see, they have the same atomic number. The same atomic number is indicated by this red color that you see. It is 1 year, it is 1 year, it is 1 year. That shows that it has the same atomic number, but it has different mass number. It has different mass number. Here, the mass number is different from this space, and here it is different from this space. You might ask, what causes the difference in the mass number? The difference in the mass number is actually caused by the difference in the number of neutrons. The difference in the number of what? Neutrons. That's what causes that difference. Here, there's no neutron. Here, you have 1 neutron. Here, you have what? 2 neutrons. These are other examples of isotopes. In exams, it might ask us, we should name examples of isotopes. Remember, we have mentioned chlorine. Chlorine has isotopes. We mentioned hydrogen, hydrogen 1, hydrogen, deuterium, and tritium. Chlorine is chlorine 35 and chlorine 37. This one is for carbon. We have carbon 12, carbon 13, and carbon 14. Yes, this is the most popular carbon that we are all aware of. But that does not mean that this does not exist. They also exist. So these are the isotopes of what? Carbon. So as you can see, what is constant there, students? This is what is constant to all of them. Each of them have the same atomic number, 6 protons. Remember the definition for atomic number? Yes, very good. Atomic number simply means the number of protons in the nucleus of an atom. So when we say they have the same atomic number, what we are saying in essence is that they have the same number of protons. So each of them has 6 what? Protons. So their electrons is where the problem is. This has 6 neutrons, this has 7 neutrons, this has what? 8 neutrons. So please, students, take note of that fact. The reason why isotopes have different mass number is because of the difference in the number of neutrons. Because of the difference in the number of neutrons. It's neutrons that cause a difference in the mass number. Take note, that's an examination question. So let's go to why we are here. Calculations on isotopy. How do we solve problems on isotopy? Let's take the first one. An element has isotopic masses of 6 and 7. The relative abundance is 1 to 12.5, which can also be written as if the ratio is 1 to 12.5. Respectively, what is the relative atomic mass of X? How do we solve this, students? Please pay attention. We have one with mass 6, and the other one is with what? Mass 7. The one with mass 6 has 1 as its abundance. So we'll multiply by the abundance of that element. You know, respectively means 6 is the owner of this one, and 7 is the owner of this 12.5. So we'll say 6 times 1 plus 7 times 7 goes with what? 12.5. 7 times 12.5. So this is 12.5. Divided by the addition of the abundance. The addition of the abundance. We have 1 and we have 12.5. If I add 1 and 12.5 together, students, what will I get? I'll get 13.5. 13.5. So how we get how we solve this question, right? We multiply the mass of each of the elements by the abundance of that particular what? Element. The abundance can come in two ways, students. Take note. The abundance can come in two ways. It can come in ratio form or it can come in percentage form. The latter is usually more popular. In this case now, it came in ratio form. This is actually a WAEC question. It was written as 1:12.5. So, for us to what? Move ahead. So, we'll multiply it. I believe our student can continue this. 6 times 1 is 6. 7 times 12.5, we'll calculate it. We'll divide everything by 13.5. At the end of the day, we should get 6.9. Our answer should be 6.9. Please, let's input our values correctly, which gives us option C. Option C, 6.9. I believe that is clear. Remember, to calculate relative atomic mass, you multiply the mass number with the relative abundance of that particular element, or the ratio, as the case may be. You do it for the first element, you add it to the second element. You do it for the first mass and you add it to the second mass. Sometimes it might be more than 2. Then you now divide it by the sum of the ratios. If it's a percentage, of course, our percentage is normally 100. If it's a percentage, you do it by percentage. So that's the answer for that question. Let's move to the second one. Chlorine consists of two isotopes, mass 35 and 37, has an atomic mass of 35.5. The relative abundance of the isotope of mass 37 is, the relative abundance of the mass of 37 is, in this case, it is clearly in form of percentage. It's clearly in form of percentage. Now look at this question, students. It's very tricky. We were not given any of the abundance. We were told to find the relative abundance of a particular isotope. We were not given that of the other one. So how do we solve it? How do we solve it? What will make it to be easily solved is because we know that it's going to come in form of what? Percentage. Because percentage is the only one that has a definite total score of 100. So how will I do it? Since I'm particular about 37, let me make 37 first. 37 times the abundance of 37. Let's represent it with X. The abundance of 37, I don't know it, so let me represent it with what? X. Plus 35. The abundance of 35, what will I multiply it by? Oh, I heard somebody say Y. No. You want us to end up in simultaneous equation, and we don't have the facilities to do that here for this question. It cannot be Y. Since we know that they will sum up to give you 100%, they will sum up to give you 100%. So the abundance of the second one will be 100 minus X. 100 minus X. I hope we get, students, because we know that it's in percentage. So we are giving 1%. So definitely the other one will be 100 minus what? That particular percentage you have been given. So you now divide it totally by 100, which is the sum of the abundance. Remember, we have been given the relative atomic mass, so which is equals to 35.5. In the previous question, we are looking for the relative atomic mass, but in this case, we have been given. So, the rest is mathematics, and I believe our students are up to the task. Can you quickly input your calculator and solve it for me?
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Okay, by now we should be true. Now let's see if your answer goes along with mine. Let's continue solving. So if I were to do this, the 7 times x is 37x plus 35 bracket 100 minus x all over 100 is equals to 35.5. What do? I cross multiply. So once I cross multiply, what does it become? 37x plus, I can open the bracket now, 35 times 100 is 3500. 35 times minus x is minus 35x. So that's what is there. Remember, it's multiplying, there's nothing here, so it's 1. It's equivalent to 1. It's multiplying 1. So it's the same thing. So 100 is multiplying 35.5. So that's 3550. Sometimes you don't need to use calculator, students. 35.5 times 100, you just need to shift it twice. 1, 2. So I get 3550. That's 3,550. So what do I do here? This is 30. This is 35x. So it looks as if it's 38. It's 35x. So 35x. So 37x minus 35x is 2x is equals to 3550 minus 3,500. It will surely give me what? 50. So divide both sides by what? By 2. At the end of the day, my x is equals to what? 25. So that means the isotope 37 has 25% abundance. While that of 35 will be, yes, very good, has 75% abundance. We just need to say 100 minus 25 and we'll get it. So they thought you will not know. They kept 75 there, but they don't know you have been properly taught. So our answer is 25 because we are looking for that of the 37. That's why I advise students, whatever you're looking for, make it your x, because some students tend to forget. So make it your x. If you had made that of 35x, some students will just stop there and rush to the next question. Or if you have made what you're looking for your x, you will not forget to. So let's move to the next question. The next question, what is isotopy? Wow, I believe we all know that. We all know the definition for isotopy. If you have forgotten, if you remember that $100 note and $100 note and $100 notes, remember that there are elements that have the same atomic number but different mass number. Why do they have different mass number? They have different mass number due to the difference in the number of their neutrons. Remember, due to difference in the number of what? Neutrons. So that's very good. I know we understand that. Illustrate with suitable example. Wow, we have many examples. We have many what? Examples. These are our questions. We have many examples. One of such examples is chlorine 35 and chlorine 37. Chlorine 35 and chlorine 37. We have hydrogen. We have hydrogen, deuterium, and tritium. The three of them are isotopes of what? One another. The next one is calculation. I believe we should be able to do this. I'll just give you I'll just push you forward so that We can do it. I believe we can do it. Two isotopes of Z with mass numbers 18 and 20 are in the ratio 1:2. Determine the relative atomic mass of Z. What will I do? Very good. That's a good one. So we'll simply say 18. We say 18 times 1 plus 20 times 2 divided by 3. How did I get 3? Very good. 1 plus 2 is 3. So we do that. 18 plus 40 over 3. So let us finish that ourselves. Whatever we get is the answer. It should be 19 point something. So let us finish that ourselves. So that ends the topic on calculations on isotopy.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Please, for any question, comments, or reaction, feel free to reach out to the link displayed on the board. Remember, keep practicing. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.